Okay, the first thing going on here is we've created three constants and named them three different things: blue, green, and red. So blue is a constant that has a value of 3, green with 5, and so on. We're doing this because we have these pins on our Arduino that we want to use that are PWM pins. And if you notice on their Arduino, have that wavy line next to them. That means they're usable for PWM, or pulse width modulation, which is what we'll be doing. So we want to use 3, 5, and 6, and we're just simply going to name them these things to make it easier to understand what they're doing. Because 3 will go to the blue LED, and 5 to the green, and so on. After that's done, we've used this setup to tell the compiler and the Arduino what the pin modes will be for those 3 that we've just used. So we want to use them all as outputs because they will be outputting signals to the LED. So remember, red just means 3, red just means 6, green just means 5, and blue just means 3. So essentially we're telling it that these pins, pin 6, pin 5, and pin 3 are all going to be output pins. Before we can do anything with them, we have to set a default or beginning mode to them. What we're doing then is saying that the red one will start out on high and the rest will start out on low. What that means is that the red one will have the max voltage that can be output, which is 5 volts, and the green and the blue ones will have 0. You just have to have a starting point there. Next thing we're doing here is we want to create 3 integers that we're going to use to iterate in a loop to store temporarily the values between 0 and 255 that the PWM can output in order to gradually change the colors. Because we don't want to just be able to do maximum red, for example, and minimum red, which would be all red or no red. We want to be able to slowly have a gradient effect where it goes through. So in order to do that, we're going to create these variables where we will loop through and store the values. So this is essentially the setup. This happens before anything else can happen and gets the program ready to actually run. So now that you have that done, you can do the main loop. Have you ever noticed on an Arduino, whenever you plug it in and run the program, it just runs the program over and over and over and over again until you unplug it, or I guess if you were hooked to a battery until the battery ran out. That's because you have a main loop called void loop. And that loop is just going to execute everything inside of it, and when it's done, go back again and keep going, like a loop. The first thing we're going to do within our loop is define our delay time. So much like we have defined constants here, we're doing it again. We're making a new constant called delay time, and you guessed it, it creates an amount of time that delays between each iteration in the loop. We'll come back to that later. But what this amount here is 10, well, 10 what? 10 milliseconds, which works out to be 0.01 seconds. So that's still quite fast. I recommend that you play with this number and see what the changes do. So to start off, we're going to have a max on the red value and then zeros on the others. So you should see in the very beginning at least an all red LED. For loops. So this is the for loop standard format for C or C++. It starts off by creating a counter. So we're creating an integer named I, and its starting value will be 0. You could start this really at anything, but usually you would start at 0. No reason not to here. And then you're going to count your way up. So that's the first argument of the for loop. The second one is, when is it going to stop? How long are we going to keep going through this loop? And in our case, we're going to go up to 254. Once the 254th number, which really is the 255th because you're starting at 0, then the loop will end. This is the counting condition. Essentially, how much are we going to count by? This is an increment of 1, right? Plus equals in C means increment by 1, or increment, that is. So this means count up by 1 with each iteration. So what's going to happen each time the loop runs? All this is done is set up the loop. So once the loop conditions have been established, we can actually run through a loop. So each time this loop runs, the red value is going to be decremented, that is decreased by 1. and the green value is going to be incremented or increased by 1. Once those values are reassigned to the variable red value and green value, they are then written to the pins. So this analog write function does just that. It takes what those values now are. Remember, they started as this, but after one iteration of the loop, for example, red value started as 255. Now, after running through this 1, it loses 1, so red value would be 254. Green value started as 0, but after one iteration, since it's incrementing, it would be 1. So at this instant in the execution of the code, the red would have a value of 254 and green would have 1. Then we're executing that delay time that we talked about for 0.01 seconds before the loop goes again. So this loop will keep running. After it's gone through one execution, it'll come back up, do it again until this condition is met, until it goes to its 255th. Then it will stop. So in the next one, it would be red value 253, green of 2, and so on and so forth until it finished. Once it finished, you're going to do the same thing again with 2 more loops, 4 loops. This one starts with a max green and min on the other 2, and decreases green and increases blue, whereas this one starts with a max blue and decreases blue and increases red. So essentially we're doing the same thing with changes to different values 1, 2, 3 times.